Right now, there's a conversation happening across millions of forums, subreddits, Discord servers, and comment sections all over the internet. And the people having it believe, with complete sincerity, that they have already solved the problem, that they have escaped, that by switching away from Windows, by moving to Linux, they are now operating on a system that is private, secure, transparent, and built entirely in their interest. And here is what nobody is telling them. Here is the part of the story that the Linux community almost never discusses openly because it threatens a narrative that a lot of people have a significant emotional investment in. Linux has its own serious problems, problems that are growing, problems that the mainstream Linux conversation systematically underestimates, problems that right now, today, are affecting people who genuinely believe they had left all of this behind when they uninstalled Windows. By the end of this video, you're going to understand exactly what those problems are. You are going to understand why the most common arguments for Linux's security and privacy advantages are more complicated than they appear. You're going to understand the specific threats, the specific misconceptions, and the specific gaps between what Linux promises and what Linux delivers in practice for the average person running it on a desktop in 2025 and 2026. And then I'm going to give you the specific, concrete steps you need to actually secure the Linux machine you are already running, or the one you are thinking about switching to. This channel has always operated from one principle: the truth the tech industry does not want you to hear. That applies to Microsoft, it applies to Google, it applies to hardware manufacturers, and it applies to the Linux ecosystem too. Nobody gets a free pass here. So let us start. Let us begin with a number. 33%. That is the Linux desktop market share on Steam as of March 2026, the highest number ever recorded in the platform's history, a number that has more than doubled in less than 6 months. Let that sink in for a second because it is genuinely remarkable and it represents something significant happening in the PC world right now. For context, Linux desktop market share sat stubbornly below 2% for most of the past decade. The joke in tech circles, told so many times it became a meme, was that every year was going to be the year of the Linux desktop. And every year, it was not. The reasons were real. Software compatibility was poor. Gaming on Linux was a painful, inconsistent experience. The hardware driver situation was unpredictable. The learning curve was steep enough that most normal people bounced off it within a week. Linux was, for most of that period, an operating system for enthusiasts, developers, and privacy advocates who were willing to accept significant friction in exchange for what the platform offered. What changed that equation was not a single breakthrough. It was a convergence of factors that happened to collide at exactly the right historical moment. The Steam Deck shipped 6 million units by mid-2025, and every single one of those units runs Steam OS, a custom Linux distribution built by Valve. Millions of ordinary gamers, people who never cared about open source philosophy or kernel compilation, were suddenly using Linux every day without even knowing or caring that it was Linux. Valve's Proton compatibility layer expanded the playable game library from roughly 9,000 native Linux titles to over 106,000, making 90% of the Windows Steam catalog playable on Linux. Valve itself is hiring engineers specifically to optimize Linux gaming performance. At the same time, Microsoft handed Linux a gift. The Windows 11 hardware requirements locked out hundreds of millions of perfectly functional computers, and the October 2025 end of support for Windows 10 created a massive population of users whose computers Microsoft had effectively abandoned. Zorin OS, a beginner-friendly Linux distribution, reported over 780,000 Windows users, migrating to Linux in the wake of those end-of-life announcements alone. European governments accelerated their public sector Linux adoption. The German state of Schleswig-Holstein completed its migration to Linux and LibreOffice in public offices. Denmark's Ministry of Digital Affairs announced its own transition. India leads all major economies with over 16% Linux adoption among desktop users. The result is that Linux is, for the first time in its history, a genuinely mainstream desktop computing platform that is growing at a pace that surprises even its most optimistic advocates. The question is no longer whether Linux is relevant for regular users. It clearly is, and increasingly so. The question is whether the people now running Linux, or considering switching to Linux, have been given an accurate picture of what they are getting. And the honest answer to that question is no, they have not. The narrative that has driven most of the recent wave of Linux adoption goes something like this: Windows spies on you. Microsoft collects your data. You have no control over updates. Your machine is being used against you. Linux is the solution. Linux is open source. Linux is transparent. Linux respects your privacy. Linux is secure. Switch to Linux and you take back control of your computer. Parts of that narrative are true, importantly true. Linux is genuinely open source, meaning the source code is publicly available and auditable by anyone with the skills to read it. There is no Microsoft account requirement baked into the core operating system. There is no recall feature continuously screenshotting everything you do and storing it in a local database. The telemetry defaults are far less aggressive than Windows 11. These are real and meaningful differences. But the narrative, as it is typically presented to new users considering the switch, commits the same error that every oversimplified tech argument commits. It compares the best version of Linux against the worst version of Windows. It compares the philosophical ideal of open source transparency against the documented worst-case behavior of a surveillance advertising operating system. And it leaves out the serious, documented, actively growing problems on the Linux side of that equation entirely. Let us go through those problems one by one. Because if you are running Linux, or you are about to switch to Linux, you deserve to know what you are actually dealing with. The first thing you need to understand is the security vulnerability situation, because the Linux community has cultivated a belief, genuine and widespread, that Linux is inherently more secure than Windows. And in some very specific, very important ways, that belief has a real foundation. Linux does have a stronger permissions model. Linux does have better separation between user space and kernel space in many configurations. The open source model does allow independent security researchers to audit the code in ways that are impossible with closed source operating systems. But here's the number that most Linux advocates do not lead with. The Linux kernel recorded 5,530 CVEs in 2025 alone. CVE stands for Common Vulnerabilities and Exposures, the official tracking system for publicly disclosed security flaws. 5,530 in a single year. That averages out to more than 15 new security vulnerabilities in the Linux kernel every single day. Now, before Linux users in the comments reach for their keyboards, there is important context. The sheer volume of CVEs in Linux is partly a product of the open source model working as intended. Because the source code is public, security researchers can find vulnerabilities and report them. More eyes on the code means more bugs get found and documented. The flip side of that transparency is that the vulnerability count is visible in a way that Windows and macOS vulnerabilities are not, because those operating systems patch things quietly without always publishing detailed CVE records. But context does not make those vulnerabilities disappear. And critically, context does not protect users who are not keeping their systems updated. Because the most significant Linux security story of the past 2 years is not a theoretical vulnerability, it is a real actively exploited one. CVE 2024-1086, a use after free vulnerability in the Linux kernel's netfilter component, specifically the nftable subsystem. This flaw, which had been sitting hidden in the Linux kernel since 2014, a full decade, allowed any attacker who gained initial access to a Linux system to escalate their privileges to root level. Root access means complete control of the machine. With root access, an attacker can disable security tools, exfiltrate data, install persistent backdoors, and deploy ransomware. CISA, the United States Cybersecurity and Infrastructure Security Agency, confirmed in October 2025 that this vulnerability was being actively exploited in ransomware campaigns. The ransomware groups Ransom Hub and Akira, two of the most active ransomware operations in the world right now, were using it as part of their attack chains. The attack pattern was straightforward. Gain initial access through stolen credentials or vulnerable network services, then use CVE 2024-1086 to escalate from a limited user account to root and own the system entirely. The patch for this vulnerability was available. It had been available since January 2024 when the flaw was first discovered. But enterprise patch cycles of 30 to 60 days meant that millions of Linux systems remained exposed during the window when exploit code was publicly available and being actively weaponized. And for home Linux users who do not have IT departments handling updates, the question of how consistently they were applying kernel security patches is worth asking honestly. This is not an argument that Linux is less secure than Windows. It is not. By most measurable metrics, Linux systems are substantially harder to compromise than Windows systems in equivalent configurations. Windows accounts for approximately 87% of global malware detections, while Linux accounts for only about 1.3%. That gap is real and significant, but 1.3% of the total global malware detection volume is not zero, and the rapidly growing number of Linux desktop users means that the incentive for attackers to target Linux desktop specifically is growing at the same rate. For most of Linux's desktop history, the threat model for home Linux users was relatively benign. Attackers focused their energy on Windows because that is where the vast majority of targets were. As Linux desktop adoption accelerates toward 5 and 6% market share and beyond, that calculation changes. The Linux ecosystem needs to reckon with the reality that popularity and security attention from attackers are directly correlated. The obscurity advantage is shrinking. Now let us talk about privacy, because this is where the gap between the Linux community's self-image and the documented reality is most significant. The dominant belief in the Linux community is that Linux is a private operating system by default. No telemetry, no phoning home, no corporation collecting your behavioral data. And for many Linux distributions, in their default configurations, this is largely true. The Linux kernel itself collects no telemetry. There is no centralized behavioral data collection baked into core Linux in the way that Windows 11 telemetry is baked into the Windows operating system. But here's what that clean narrative leaves out. Linux is not a single product. Linux is a kernel, and what most people install when they install Linux is a distribution, which is a specific packaged combination of that kernel, desktop environment, system tools, package manager, and bundled applications assembled by a specific organization with its own policies, its own financial interests, and its own approach to data collection. And some of those distributions are beginning to behave in ways that should make their users pay attention. Ubuntu is the most widely installed Linux distribution in the world. It is the starting point for the majority of new Linux users. It is the distribution that most guides, tutorials, and YouTube videos point beginners toward. And Ubuntu is developed and maintained by Canonical, a private company with a commercial business model that includes cloud services, enterprise support contracts, and technology partnerships. Ubuntu has a package delivery system called Snap, developed and controlled by Canonical. Snap packages are containerized applications that Ubuntu increasingly installs by default, including Firefox, the default browser on Ubuntu. Unlike traditional Linux packages that are managed entirely by the local system, Snap packages communicate with Canonical's Snap Store infrastructure. Researchers have documented that Snap packages phone home to Canonical's servers to check for updates, verify package signatures, and report usage information. Most recently, a privacy monitoring tool called Little Snitch, which tracks outgoing network connections from your operating system, released its first Linux version and immediately discovered something notable. Ubuntu systems make approximately 9 network connection attempts per week to external servers in their default configuration. For a community that frames itself as having escaped corporate surveillance, 9 unprompted outbound connections per week from the operating system itself is a detail worth examining carefully. On top of that, Ubuntu introduced a new telemetry system in its 2015 release called Ubuntu Insights, which replaces the previous Ubuntu report system. Ubuntu Insights collects hardware data, including your CPU model, GPU model, RAM amount, screen resolution, TPM status, and encryption status, and sends it to Canonical's servers once per month. Canonical frames this as anonymous, opt-in, and transparent. And to be clear, the framing is mostly accurate. The data is stored in a plain text JSON file in your home directory that you can read yourself. The first time it runs, it shows you the report before sending it. The opt-in is a real opt-in, not a dark pattern disguised as a consent request. But the key detail is this. Ubuntu Insights represents a shift from a one-time snapshot to a monthly recurring data transmission. Canonical's own statement explained that this gives them more consistent and up-to-date data about how their user base is evolving over time. From an engineering perspective, that is a reasonable justification. From the perspective of a user who switched to Linux specifically to escape regular operating system telemetry, it is a development worth understanding and consciously choosing to opt out of. None of this means Ubuntu is spyware. It is not. The transparency around Ubuntu Insights is meaningfully better than the transparency around Windows 11 telemetry. You can see exactly what is being collected. You can opt out cleanly. The data being collected is hardware information, not behavioral profiles. The comparison to Windows is not remotely close in terms of scope or invasiveness. But the Linux community's habit of presenting Linux is entirely free from any data collection by the operating system or distribution developer is a simplification that is becoming less accurate as the major distributions develop more sophisticated relationships with their user bases. Here is another gap in the Linux privacy narrative that almost nobody talks about honestly. Choosing Linux does not protect you from the primary surveillance mechanisms that most people are trying to escape. Think about what actually tracked your behavior on Windows. Yes, Windows itself collected telemetry. But the bigger behavioral tracking infrastructure was not coming from the operating system. It was coming from your browser, from Google's tracking network embedded across 85% of the top websites on the internet, from the advertising ecosystem that follows you from site to site, from the applications you use that have their own data collection practices entirely independent of the operating system, from your Google account if you use Gmail, Google Calendar, or Google Drive, from the apps on your phone that are syncing data to cloud services regardless of what your desktop OS is. If you switch from Windows to Linux and then open Firefox or Chrome, sign into your Google account, and browse the same websites you always have, you have removed one layer of the data collection architecture, the operating system layer, but you have left intact the much larger and more commercially significant layer, the browser and application tracking infrastructure that follows you everywhere, on every operating system, on every device you own. This does not diminish the value of removing the Windows telemetry layer. Every reduction in data collection has value. But the Linux migration conversation routinely implies a degree of privacy protection that is far more comprehensive than what switching the operating system actually delivers without deliberate additional configuration of browser, search engine, DNS, and application choices. Real privacy on Linux, privacy that meaningfully reduces your exposure to behavioral tracking and data collection, requires the same browser and search engine decisions that we covered in our Windows 11 video. Firefox with strict enhanced tracking protection. A privacy-respecting search engine like DuckDuckGo or Brave Search instead of Google. DNS over HTTPS or DNS over TLS to prevent your internet service provider from seeing your browsing queries in plain text. Disabling telemetry in specific applications that collect it, using uBlock Origin for comprehensive tracker blocking. Configuring your system's hosts file or using a network-level ad blocker to block known tracking domains at the infrastructure level. Linux makes these configurations possible without fighting the operating system. That is a genuine and important advantage over Windows. On Windows, Microsoft is actively working against some of these protections, limiting ad blocker capability in Edge, routing start menu searches through Bing, and making privacy settings hard to find. On Linux, nothing in the operating system is working against your privacy configuration choices, but the configuration still needs to happen deliberately. The switch to Linux alone does not create a private computing environment by default. Let us talk about the driver situation, because this is a hardware channel, and the driver situation on Linux is one of the most significant hardware-level stories that new Linux users consistently underestimate until they run directly into it. Linux has excellent driver support for a wide range of hardware. AMD graphics cards, in particular, are exceptionally well supported on Linux. AMD's commitment to open-source driver development means that Radeon GPU drivers are built directly into the Linux kernel, requiring no separate installation, no firmware agreements, and no proprietary software to function at full capability. This is one of the reasons that approximately 70% of Linux Steam users run AMD processors, compared to roughly 39% of Windows Steam users. The open-source driver story for AMD hardware is genuinely excellent. NVIDIA's situation is more complicated. For most of the past decade, NVIDIA's Linux support was infamous for being unreliable, requiring proprietary closed-source drivers that were not included in most distributions, breaking with kernel updates, and creating the kind of frustrating dependency on a single company's goodwill that the open-source community philosophically rejects. NVIDIA has been improving its Linux support significantly in recent years and has taken steps toward open-source driver development for newer GPU architectures. But the situation remains more complex than AMD, and many Linux users with NVIDIA hardware still encounter specific scenarios where driver behavior differs meaningfully from the Windows experience. Wi-Fi adapters are a persistent pain point. Many Wi-Fi adapter manufacturers, particularly those in the cheaper market segments, do not provide Linux-compatible drivers or provide drivers that are poorly maintained. The result is that a Wi-Fi adapter that worked flawlessly on Windows either does not function at all on Linux, works only at reduced speeds, or requires manual driver installation from sources that may not be maintained or verified. For desktop users connected via Ethernet, this is irrelevant. For laptop users, it is potentially a deal breaker. The broader point is that the hardware compatibility landscape on Linux rewards users who do their research before making hardware purchases and penalizes users who assume that anything that works on Windows will work identically on Linux. That assumption works for a majority of common hardware. It fails for enough hardware configurations, particularly involving Wi-Fi adapters, certain webcam models, fingerprint readers, and some newer laptop-specific features that new Linux users need to approach hardware compatibility as something to verify actively rather than assume. Let us talk about software compatibility. Because the gaming situation has improved dramatically thanks to Proton and the Steam Deck effect, but the software landscape beyond gaming has real gaps that the Linux adoption conversation consistently glosses over. The professional creative software situation is the most significant. Adobe Premiere Pro does not run on Linux. Adobe Photoshop does not run natively on Linux. Adobe After Effects does not run on Linux. The entire Adobe Creative Cloud ecosystem, the software stack that a significant portion of professional video editors, photographers, graphic designers, and content creators depends on, is a Windows and macOS exclusive. Some open source alternatives exist. DaVinci Resolve from Blackmagic Design has a genuinely excellent Linux version that is the industry standard tool for color grading. GIMP is a capable Photoshop alternative for many use cases. Kdenlive, Shotcut, and OpenShot cover video editing for users without professional grade requirements. Inkscape handles vector work for many designers. But for professionals who need the specific features and industry compatibility of Adobe software, Linux creates a genuine workflow problem that has no clean solution today. Microsoft Office is a similar story. LibreOffice is an impressive open source alternative that handles the vast majority of document, spreadsheet, and presentation tasks competently. But there are documented compatibility issues with complex Word documents, Excel macros, and PowerPoint presentations. For individual users doing straightforward work, LibreOffice is more than sufficient. For business environments where documents are shared with Windows users who rely on specific formatting, macros, or features, the compatibility gap creates real friction. Microsoft 365 web applications run in the browser on Linux and cover many use cases, but the offline capability, performance, and feature completeness of the native Windows applications are superior. Enterprise software and specialized industry applications are a consistent blind spot. Accounting software that smaller businesses rely on, industry-specific CAD and engineering tools, healthcare electronic medical record systems, legal document management platforms. Many of these applications are Windows exclusive, either because they were built before Linux desktop was a consideration, because their vendor has no financial incentive to support the Linux market, or because they depend on Windows-specific system features. For users in industries that rely on this category of software, Linux is not yet a viable full replacement without running Windows in a virtual machine alongside it, which introduces its own complexity and hardware resource overhead. Now let us talk about the update management reality, because this is one of the areas where the Linux conversation most significantly misleads new users. One of the genuine advantages of Linux is control over updates. On Windows 11, Microsoft can push updates that you did not request, that change default settings without your consent, and that introduce features you explicitly do not want. Linux gives you substantially more control over when and how updates are applied. That is a real advantage and a meaningful one, but that control comes with a responsibility that most of the Linux promotion material underemphasizes heavily. Maintaining a secure Linux system requires consistent attention to system updates, particularly kernel security updates. The 5,530 CVEs in the Linux kernel in 2025 were not theoretical. They were real vulnerabilities, many with published proof-of-concept exploit code, actively being used by attackers who understood that a significant population of Linux users would not apply patches promptly. The CVE 2024-1086 story we discussed earlier illustrates this precisely. The patch was available. CISA added it to the known exploited vulnerabilities catalog because attackers were actively using it. The organizations and users who got compromised were the ones whose patch cycles did not move fast enough to close the window between public exploit availability and installed fix. On Windows, the forced update model that frustrates so many users also means that security patches are applied, often automatically and without user involvement. The patch compliance rate on Windows systems is, paradoxically, often better than on systems where users have more control, because control also means the ability to defer, delay, or ignore updates indefinitely. Linux users who value the control the platform gives them over updates need to take seriously the responsibility that comes with that control, enabling automatic security updates for at minimum the most critical components. Monitoring CISA's known exploited vulnerabilities catalog for Linux kernel CVEs, understanding which kernel version their distribution is running, and whether it is within the active security maintenance window. These are not optional practices for security-conscious Linux users. They are the table stakes of running a system that is actually as secure as the Linux migration narrative implies. Here is the distribution choice problem that nobody in the Linux community wants to talk about bluntly. The fragmentation of the Linux ecosystem, the fact that there are hundreds of Linux distributions ranging from rock-solid to barely maintained community projects, means that the security and privacy properties of a Linux installation vary enormously depending on which distribution you chose, how that distribution is configured, and how actively its security team responds to upstream kernel vulnerabilities. Ubuntu's long-term support releases receive security updates for 5 years from Canonical with a standard support contract and up to 10 years with an extended security maintenance subscription. Fedora's releases are supported for approximately 13 months before requiring an upgrade to stay on a maintained version. Arch Linux, popular among advanced users and increasingly among gamers using distributions built on top of Arch like Manjaro and EndeavourOS, is a rolling release distribution that receives updates continuously but also requires more active user involvement to maintain correctly. Linux Mint, one of the most popular beginner-friendly distributions, bases its releases on Ubuntu LTS versions and inherits their support windows. None of these is wrong. They represent different engineering and support philosophies with different trade-offs. But a new Linux user who chose a distribution because it looked good in a YouTube comparison video without understanding that distribution's update model, security team, and support lifecycle may be running a system that they believe is being maintained when it is actually approaching or past its end of support date. The principle of open source transparency is often invoked as the solution to this problem. Because anyone can read the code, the community collectively maintains security. This is true in aggregate and at the level of the kernel and major components. It is significantly less true for the long tail of smaller distributions and community-maintained packages, where security response times can be much slower and the resources available to audit and patch vulnerabilities are much more limited. Now, here is where this video takes a turn. Because everything I have described so far is not an argument that Linux is bad. It is not an argument that you should not be running Linux or that you should switch back to Windows. If you are on the Hardware Report channel, you likely understand that every platform has trade-offs and that no technology decision is consequence-free. Linux is genuinely excellent. The growth in Linux desktop adoption is genuinely good news for users who care about privacy, security, and computing freedom. The open source model is genuinely more trustworthy than closed source alternatives in the ways that matter most for long-term platform health. The community that develops and maintains Linux is filled with engineers who care deeply about security and who respond to disclosed vulnerabilities with impressive speed at the kernel level. What Linux is not is a magic solution that makes all of these problems disappear because you chose the right operating system. The problems we have discussed are real. The security vulnerabilities are real. The telemetry in some distributions is real and growing. The software compatibility gaps are real. The driver inconsistencies are real. The responsibility that comes with update control is real. The Linux users who are going to have the best outcomes from this migration wave are the ones who go in with accurate expectations, understand what choices they need to make actively, rather than assuming the platform handles everything by default, and apply the same critical thinking to their Linux installations that they applied to their Windows configurations. So let us talk about what you actually need to do. Here is your action plan for running Linux in a way that actually delivers on the security and privacy properties the platform is capable of providing. The first decision, and the most important one, is distribution choice. If you are new to Linux, 3 distributions stand out as the right starting points depending on your priorities. Linux Mint, specifically the Cinnamon Edition, is the closest to a Windows-like experience with excellent hardware detection, strong community support, an intuitive software manager, and a conservative update approach that prioritizes stability. It is based on Ubuntu LTS and inherits Canonical's security support structure while making different default choices than Ubuntu, including not pushing snap packages aggressively. For users migrating from Windows who want a familiar, stable environment, Linux Mint is the most consistently recommended starting point in the Linux community, and for good reason. Fedora, the community distribution sponsored by Red Hat, is an excellent choice for users who want to run genuinely cutting-edge software and stay close to upstream Linux development. Fedora's security team responds to CVEs quickly. Its Flatpak application packaging model gives you access to a wide range of software with good sandboxing, and its rolling feature release model means you are always running a relatively current version of the software stack. The 13-month release cycle requires periodic system upgrades, but the Fedora upgrade process has become much more reliable in recent years. For Hardware Report viewers who are specifically interested in gaming performance, Bazzite or CachyOS represent a third option. Both are gaming-focused distributions that come pre-configured with Proton, optimized kernel parameters, and gaming driver support. Bazzite in particular is an atomic, image-based distribution, meaning system updates are applied as complete, verified system images, rather than individual package updates, making the system significantly harder to break and easier to roll back when something goes wrong. After you have chosen and installed your distribution, your second action is to disable any telemetry or data reporting that your distribution includes. On Ubuntu, this means opting out of Ubuntu Insights during installation when prompted. If you have already installed Ubuntu and missed the prompt, you can disable it by running the command Ubuntu Insights Disable from your terminal. You can verify what data the system would send by checking the file at the path home, your username, .cache, Ubuntu Insights before opting out so you understand exactly what you are removing. Third, enable automatic security updates for critical packages. On Ubuntu and Debian-based systems including Linux Mint, this is the unattended upgrades package. Enable it and configure it to automatically apply security updates without waiting for you to manually run an upgrade command. On Fedora, the DNF automatic package serves the same purpose. Set it to apply security updates automatically and only security updates, which reduces the risk of an automatic update breaking something while ensuring that critical patches are applied promptly. This is the single most impactful security decision you can make on a Linux desktop after choosing a well-maintained distribution. Fourth, configure your firewall. Most Linux distributions do not enable an active firewall by default, because in a home network environment without incoming connections, the risk is lower than on a public network. But enabling the uncomplicated firewall, which is the UFW package, is a straightforward baseline hardening measure. Run sudo UFW enable and sudo UFW default deny incoming in your terminal. This blocks all unsolicited incoming connection attempts while still allowing you to initiate outgoing connections normally. Fifth, address your browser and search engine situation immediately. Firefox is the correct default browser choice on Linux, as it is everywhere. Enable strict enhanced tracking protection in Firefox's privacy settings. Install uBlock Origin from the Firefox extension store. Change your default search engine from Google to DuckDuckGo, Brave Search, or Startpage. These are the same browser hardening steps that matter on every operating system, and they matter here because they address the tracking infrastructure that exists above the operating system layer where Linux's privacy advantages cannot reach. Sixth, use Flatpak applications where possible for software outside your distribution's repositories. Flatpak applications run in sandboxed environments with declared permissions, meaning they cannot access files, hardware, or system resources beyond what they explicitly request. This significantly reduces the blast radius of a compromised or poorly behaved application. Most major applications are available as Flatpaks, and the FlatHub repository is the primary source. Seventh, encrypt your drive if you did not do so during installation. Full disk encryption with LUKE, which stands for Linux Unified Key Setup, is available during the installation process of most major distributions. If your drive is not currently encrypted, the data on it is accessible to anyone with physical access to your machine. On a laptop especially, full disk encryption is a baseline security measure. If you did not enable it during installation, the process of enabling it retroactively is more involved and generally requires reinstalling the operating system with encryption enabled from the start. Eighth, set a strong login password and disable automatic login if your installation enabled it for convenience. Linux's security model relies significantly on the privileged separation between your regular user account and the root account that requires authentication to access. Automatic login bypasses the first layer of that protection. Ninth, if you are running NVIDIA hardware, verify that your GPU drivers are correctly installed and understand whether you are running the open source Nouveau driver or NVIDIA's proprietary driver stack. For gaming and GPU-intensive workloads, the proprietary NVIDIA driver delivers significantly better performance. For general use, where privacy matters, the open source Nouveau driver avoids a dependency on NVIDIA's proprietary software. Know which one you have and make a deliberate choice about which one you want. 10th, review the applications you install from outside your distribution's repositories. Linux's security reputation is built substantially on the curated, maintained nature of distribution package repositories. Every package in the official Ubuntu, Fedora, or Debian repositories has been reviewed and is maintained by identifiable people, accountable to the distribution's community standards. Applications installed from random GitHub repositories, PPAs from individual developers, or Snap and Flatpak sources outside the main curated stores do not have the same level of review and could introduce security risks or data collection that you did not agree to. Let us pull back to the bigger picture, because we have covered a lot of ground and it is worth being direct about what it all means. The wave of Linux adoption happening right now is one of the most significant developments in personal computing in a decade. The forces driving it: Windows 11's hardware lockout, end of Windows 10 support, the Steam Deck's normalization of Linux gaming, growing awareness of privacy issues with proprietary operating systems, European governments moving their workforces to open source alternatives are all real and all accelerating. For the right user with the right expectations and the right configuration, Linux in 2025 and 2026 is a genuinely excellent desktop operating system. Faster on older hardware than Windows, more configurable at every level, built on a foundation of code that is publicly auditable, free from the specific Microsoft surveillance infrastructure we covered in our Windows 11 video, more respectful of the user's time and autonomy when it comes to software installation, update management, and system control. But the Linux community has done new users a disservice by presenting the platform as a solution to problems it can only partially address, while underselling the responsibility the platform places on the user and the real security challenges that are growing as Linux desktop adoption grows. 5,530 kernel CVEs in a single year is not a talking point for Windows defenders to dismiss Linux security. It is a documented reality that Linux users need to understand and respond to with consistent patching practices. Ubuntu phoning home monthly with hardware data is not the surveillance catastrophe of Windows telemetry, but it is a development that a privacy-conscious Linux user should know about and explicitly opt out of. The Snap ecosystem's connection to Canonical's infrastructure is a detail worth understanding. before you assume that everything on your Ubuntu desktop is operating without any corporate intermediary. None of these problems are reasons to avoid Linux, but all of them are reasons to approach Linux with the same critical, informed perspective that you bring to every hardware and software decision. Because on this channel, that is what we do. We give you the truth that the tech industry, including the open source tech community, does not always volunteer on its own. Your machine, your data, your decision, make it with accurate information,